Hello, everyone, and welcome back. We are about to start on our Deci blocks. But before we do that, let's maybe just review quickly the ones that we just finished in the pattern blocks, the regular set that we start with. So we had our hexagon, we had our trapezoid, we had the rhombus, and we had the triangle. And then we added in the double hexagon and the chevron. And so just to quickly review, one of the things that we did was we looked at how do we layer each one of these, and I'll take these two out for now so we can just start on just the basics. We are going to bring the chevron back in again later, but maybe not right now. So what we did is we looked at how many different things can we layer each one of these with. What didn't matter what color went on top of them as long as everything fit right on top and there was nothing hanging out or any gaps in it. But then the specific ones that we looked at were when we got the same colored layers on there, how did that help us to determine the value of that block and what else, what other information did it give? So maybe let's just quickly review that. I'll pause the video. If you can grab one of each of those blocks, and then what I'd like you to do is cover them. If they can be covered with one color only, what would it be and how many would there be on each one? All right, I'm back again. So hopefully you had a chance to do some layering as well. And so I took our rhombus, our blue is underneath, and it fits with two different triangles on top. And mine are a different shade, and I suspect that's probably because it depends on which manufacturer we got them from. I'm going to leverage that to my advantage though. The trapezoid had three triangles that fit on top of it. And yes, I can put a blue, but it's not going to be the same color because I still need a green then. The hexagon, I was able to put 6 different triangles on. I can also put 3 rhombus on or 2 trapezoids on. So how that helped us, it was able to help us determine what the unit fraction would look like for that particular shape. So in this case, 2 triangles meant that the unit fraction of 1/2 was represented by 1 triangle. So I'll use the dark one as a quick illustration. Here, because I had 3 of them, that meant that the unit fraction represented for the trapezoid was 1/3 because it took 3 triangles for me to do that. And equally, when I had the hexagon, I have 6. So here's the picture of 1/6. This is my unit fraction there. But the hexagon also had other possibilities. I could use 3 of the rhombus or rhombi, and I can rhombuses, I guess. Put that on, so that means 1, 2, 3. So this is 1/3. Or I could have used 2 trapezoids, and so this is 1/2. So we had a number of different fractions possible: 1/2, 1/3, 1/3, 1/6, 1/2 again. But there's a whole bunch of fractions that we are missing here and that we would still like students to be able to have access to. I can add, I can do all kinds of addition questions with this, and I can definitely put a, what's a trapezoid plus a rhombus? When we put them on top of a common shape, I need a common color. We did all that in the last video, but there's only going to be so many fractions that I can do given the starting points that I have here. So one of my finishing points in the last video was, could you find a way to express tenths? So I'm just going to slide some of mine off the page here for a second. And I'm going to grab another, move this guy up a bit. So we know this is 6th because I have 6 triangles on here. So that gives me a way of measuring how many are all those 6 parts. If I had taken the chevron and added it on, I now have a shape that should represent tens. And how do I know that? Well, because remember that the chevron was made of 2 of our rhombus, and each rhombus has 2 triangles. So if there's 6 here, 7, 8, 9, 10. So there's one way that I can come up with tens. So students need to realize that I can change the value of them by creating a different whole and starting from that point. So it's very likely that we can do that. So Deci Blocks offers us that opportunity where they have created some new shapes that allow students to go beyond just the typical 1/6, 1/2, and so on. I'm just going to lift these up. And these are the additional pieces. These aren't in exclusion of. We don't do these or use these without using the other pattern blocks. So if you have these in front of you right now, and a question that I might ask students might be, what are your wonders? You're used to seeing these typical ones. So what are your wonders about these ones versus the ones that we just finished, right? What are your thoughts about these? And so just giving them that opportunity to ask questions, put the wonders up on the board, and see what they come up with. And then I think what I would ask you to do at this point is you could either assign groups different shapes and say, your group is going to get this one, your group is going to get this one. But better would be for them to all be able to work in pairs or in groups of 3, do the same activity that we just finished with these shapes. What layers can you put on top of each of these, whether it's the same color, not same color? And then what colors can you put on here that will only be the same color? So let's pause the video again and let's just go for anything that's not the same color. Let's see what they come up with. Can you fill all of these new shapes with anything that is a mixed bag of colors? And then come back when you're ready. All right. So in the interests of space, I didn't do all of the possibilities, but what I wanted to just show you was the purple has all kinds of different combinations that we can. And just because mine are in this order, we'll just assume that if you have a blue and 2 greens that basically have the same thing, even if they were flipped around, we can tell that to students. But really, I have lots of different ways that I can create this. The pink trapezoid, lots of different possibilities that I can come up with. Same thing with the large green triangle. I was running out of small green triangles so that you can see right here. I would have normally just put them in there, but you can see how they would actually go in. And I have a hexagon, but I can also use one of the new Deci blocks and fit that in here as well on a large green triangle. The white one, I can use a hexagon and another triangle would go there, or I could use a trapezoid and 2 rhombi, or trapezoid rhombi 2 triangles. The black trapezoid has all kinds of possibilities as well. So I would be able to stick a lot of different things in here. I could even use the hexagon if I wanted to. The boat has got tons of possibilities. I could put a trapezoid at each end. I could put 2 triangles here and a trapezoid there, or the other way around. So again, there's lots of different ways. I could use the red trapezoids in the middle. So these blocks you're starting to see are starting to use familiar sizes that we already know. And now I'm going to leverage the knowledge of my original pattern blocks and what they represented to start to figure out how these new ones are going to fit into the scheme of things. So now I'm going to pause the video again, but what I'd like you to do is go back and just take the new shapes and layer them only with 1 color. Now it's very possible that some of them will only have 1 layer. It's very likely that some of them will have more than 1 layer, but see what you can come up with. So I'll pause my video and then I'll see you back in just a minute when you've had a chance to go through and layer them with 1 color only. Well, how did you do? Obviously, there are lots of possibilities, but there's also the need for lots of green triangles. It doesn't take long to run out, that's for sure. So you found that the dark purple really only had 1 way that we could layer it, and that was with dark green triangles, and there were 4 of them. You have the pink trapezoid, and again, I could only layer it with green triangles. There's no other way to get other combinations, even using our originals, to fit on there with 1 color. The same thing was true of our large green triangle. I could use 9 small green triangles, or because it's 9, I know that in my original, a trapezoid had 3 triangles. I could use 3 trapezoids to layer a dark green or light green, the large green, sorry. The black trapezoid, although it's an even number, you think when you count them up, there's no way for me to get different colors on there. So again, this is one of those ones where we had to use the triangles. Same thing with the white one. And then when we get to what the brown one is, it's often called the boat, I was able to layer it with triangles or with a rhombus. So now here's my next question for you. Now that you know what each of the colors, the new colors are, what does one of these represent in each of the colors? So tell me what the unit fractions would be for each of the colors. And then what I'd like you to do is take the original shapes and the new shapes and order them from the smallest amount to the largest amount and write their unit fractions beside them. Okay, so I'll give you just a second to think about what numbers you're going to put down and then what order you're going to put them in. And then I'll come back and we'll just confirm we're all on the same page. All right, so as you were going through and looking at each of the layers with the triangles, it becomes evident that you can count them up and see what each value of one of those triangles would be on the shape. But if we just started then and said that one triangle would be considered one unit, if we want to talk about area, this is moving ahead, obviously not into fractions, but it could be a unit squared. That could be the same thing you could call it. Then the rhombus with the triangles, there would be 2 triangles, and one triangle represents 1/2. In our trapezoid, the small red one, I fit 3 triangles on there, it's 1/3. In the purple triangle, one of the new Deci blocks, it becomes 1/4. Then it becomes 1/5. And they're just putting them in order. Our yellow hexagon, 1/6. Our white shape, 1/7. Our black trapezoid, 1/8. The large triangle, 1/9. And our boat, 1/10. And let's keep in mind too that our green triangle could also have been done with the red trapezoids on it, 3 of them. So it has the potential of also representing 1/3. Depends on what unit it is we want to talk about. But it does have a conversation piece that we can talk about then is how does 1/3 always equal the same thing, or does the amount have to be the same? So if I were to talk about the triangle here, if I put one triangle onto my red, grab one here. So there's my red. And if I were to throw a triangle on top of that, I might need to borrow one from underneath here. So if I put one underneath or on top of this, versus when I put a red trapezoid into the large green triangle, then we can also have that conversation about how does this 1/3 be called the same thing as this 1/3? And so it gets again to that conversation about it depends on what the whole is. But it allows students to see that the 1/3 is a representation of a whole. It represents the same thing. It doesn't have to be the same size though. And that's just a great conversation for students to be able to experience and to see. So you might want to ask students to do questions such as, how can they represent 1/2? How can they represent 1/3? So clear off your page right now and put your blocks back again. I'll pause mine just for a second and then come right back. So I'm just showing you a list here, and I just threw some numbers down. It doesn't mean that these are the only ones that we would look at. But again, when we look at the new curriculum, they're working generally on denominators that are 12 or less from grade 3 down, and certainly not much larger when you get into 4 and 5 as well. So these would be kind of common ones. And when we start thinking about imperial measures, We would want 1/2. We would want 7/8, 1/8, 1/4. Those would be common numbers that we would want them to be able to show us a representation of as well. So just for example, 1/2, what can they show me that would be a half? Which of the shapes can give us a half? Well, we know I can do this one. These are not the only ones, but I'm just going to start with these. So the rhombus, I could do it with the hexagon. I could do it with the boat. I know that the boat has 10. I just need to find 5. And what I also want to point out is that although in the Deci blocks, they don't show the chevron, I do use it because students are familiar with it. And so where they see it, then they can definitely put that in there. So there's no reason we couldn't include that one as we go along. So we might ask them to find ways that they could represent 1/3. What are ways that they could represent 2/3, 4/5, 7/8, 3/10, or any other number that you come across at this point that you think would be valuable for them. And so sometimes it's also important for the students to see not even so much what it is that they have to be able to make, as much as what don't they see. I can flip this around and say it doesn't have to be always just what I build on top of it. I could give them a question that looks something like, let's say, even the first one here. So what fraction of the hexagon is not covered, right? So if I know that the hexagon has a unit fraction of 1/6, I should be able to tell you that it would take 5 other ones to cover this. So 5/6 is what's being missed. That's what I don't see. So it doesn't always have to be the visible piece. This would be another question where I could ask the same thing. What fraction of the large green triangle is not covered? So I have the white one. This is hard to see. I have the white one sitting on top of the green one. So I would need to know a couple of things. I need to know what the white one is in total if I don't know what the green one is, and then I can just add the 2 pieces at the end. Or if I know that the green covers 9 and this sits on top of it, which is 7, then here's my 2, 9 minus 2 is 7. Again, there's just simple ways that they can do it, but it doesn't always have to be what is it that's on top? It could be what is not. What is it that you're not seeing? The one that's hidden on the bottom here, let me just grab that one for you, is, again, what part of the large green triangle is not covered? So again, I need to know something about what sits here. Maybe I need to know that it's this pink one that would fit on the bottom. And what is that pink one worth, right? So again, I have all kinds of different possibilities that I can do with the students, that it doesn't always have to be quite as simple as just what I see in front of me. These come from a resource book. I'll show you that at the end that would give you options to look at different kinds of questions. I could even look at a question that looks something like this. Okay, I'll bring it down just a bit. So here's 2 ways of showing a third. Okay, how are they related? Talk to me about that. This is a great formative assessment question for you to figure out what their thinking is. So it's not just show me a third, but these are a third. I'm telling you that they're labeled a third. So talk to me about that. How can they both be a third? How does that come about? So it goes to that conversation again that we had about, you know, how does the whole affect what the question is that I'm going to be working on? Okay, so let's try an addition question with the Deci blocks. I know we did some with the other one, but I just want to make sure that we leave you with a couple. So we might have a question. I'll just put them here. I'll just fold this so I don't have to get all of that. There we go. So I can see that I have 3/4 and 1/2. So we could ask the students to come up with, could they first of all show us 3/4? And if so, what does that look like? So maybe I pick my purple triangle because I know that that comes into 4s. So I'm going to put 3/4 onto that. And if you remember the rule that we did in the pattern blocks when we just did the basics, we said to add a fraction, I can't just grab a shape and put it together and create a new shape. So I have to have a common color, because a common color means I have a common shape in which I can work from. So in this case, I'm going to have to really think about, I have 3/4 and I want to add to that 1/2. So again, I'm going to just take this off so it doesn't keep adjusting. Here's my 1/2, or sorry, my 3/4. And to that, I want to add 1/2. So what if I have no idea kind of what shape I should grab? And the only thing I can think of is I'm going to go with this one. This is not the only way to get a half, right? I could go with another shape that shows me half. I could go with a rhombus that shows me half. I'm just going to pick the hexagon. Okay. So what I have right now is the purple triangle would have 4 to completely cover it. This one, if I think about what do I need, if I change these to the same color, what do I need to replace this? And that would be 3. Okay, we did that in the last video. So put my 3 on there. So I've changed them to the same color, but really I'm not dealing with the same shape. I need something that would be a common shape. So there's one way that I can do that, and that I could say, and you're going to see where we're going to go with it. This one I need 4 to fill it. This one I need 6. So maybe if I could find a number where they both fill the same amount, then I can compare them. So if I take another triangle, okay, and if I had 3/4, so that would give me 4 here, and 4 here is 8. Here it's 6, and 6 is 12. Well, there's a number. I could probably make that work because these add up to 12. If I add one more purple triangle, I now have 12 pieces. This 4 would have been here, 4 would have been here, 4 would have been here. Whoops. Let me just move that up a bit so you can see them. So each purple triangle gets their 12, or their possible 4, and we're only showing 3/4 because that's all I wanted. So 4, 4, and 4 is 12, 6 and 6 is 12. So 12 is now my common value if I was working on my fraction strips. And so the question becomes, 3/4 is how many 12s? Well, I can see 3/4 here, 3, 3, and 3. So that's 9 12s. 1/2 is 3 plus 3 is 6 12s. So 9 of the 12 that we built plus 6 of the possible 12 that we built is how many? I end up with 15. So what does that mean? Well, we can do what we did before. And that is, let's build up the pieces. So I'm going to add my extra triangle to each one of these. That's going to give me 1 whole 12, right? Remember, it was on 12s. So all of these together make 1 whole. And I still have 3 12s left over. That means 1 and 3 12s. So 1 and 1/4. And if you think about it, is it a quarter? Of course it is, because I would need 4 of these to finish this off. So it's another way for students to do their addition. They can use the fraction strips and we'll follow their fingers down, find the equivalent values. Same color means same denominator in using the fraction strips. In this case, the same amount covering both of my shapes was my common denominator. And yes, eventually we are going to want to show them that 3/4 would be the same thing as multiplying. If I was going to say 3/4 is something out of 12 pieces. In other words, I needed 3 triangles to get to 12. So that means I multiplied this by 3 to get 9 out of here. So we show them that pattern, but we don't just go straight to the algorithm. We want them to see what it is that they're finding so that they understand how that works. All right. So now the concern that some people and I have maybe is that we have the Deci blocks, right? And they're absolutely wonderful because now I have no limits. Now I can say, can you find 1/10 and add 1/4, right? I have the tools to do it. But you may not have these blocks yet, and they're a great addition because they really do allow students now to come up with anything we want. So for example, if this is a 10, and I said, I'd like you to make a 12. Well, I can make a 12 this way. We saw that a 12 could be a double helix that looked like this. Or I could take the boat and slide a blue piece in, and now I have a 12. So that they learn that they can create a new shape that will reflect the denominator or the pieces that I wish to work under. And once I put that in, that might even change what I can actually find as an equivalent. So for example, when I put that on, right, I can change it. Now I could also build it with this. Then I can also add this on the end. So it changes the dynamics of what I can put on and build. It allows students to think in terms of fractions being not just a fixed number, but that we can actually create any portion of a whole that we wish. We just need to decide, what does that whole need to look like? And how many pieces does it need to have? So there's my 14, for example. So again, this just offers students an opportunity to go ahead and figure some pieces out. Now, this is not the only thing that we would use Deci blocks for. We would be able to use them for patterning. We'd be able to use them for measurement. So I will be doing that again when we do the pattern blocks for everything other than fractions. So that's a different folder that you'll find them in. But behind this recording right now, you're going to have another recording. It's attached to it. And that will be allowing you to manipulate, in case you're watching this but saying, I don't have Deci blocks, I don't know what to do with this. I'm going to do it virtually with you, and I'll share a link that you will be able to go in and take. And then from that link, you can join me in grabbing each of the Deci blocks and doing them virtually. So maybe you want to use those on a smartboard. Maybe you want to just use that in the interim until you get some, or maybe that's what you want to use. You've got the tools that every child has access to it digitally, then we could use them that way as well. Remember that manipulatives physically are great for the brain. But a virtual manipulative is still a manipulative, right? We can still use those. It's not something that's defined just because I can pick it up as a manipulative. So our goal is always to do hard and fast finger pieces. But if we don't have that and we go virtual, then that is always an alternate tool that we're going to use. So I will see you in the next video. Hi, everyone, and welcome back. We are going to do the same thing with the Deci blocks, only we'll do it virtually this time in case you don't have them accessible to you, or you don't know that you're going to use them all. So we're going to sign into Braining Camp. If you have already got a login to that, you might want to bring that up. If you haven't, it's just brainingcamp.com. And you can go in and do a 30-day trial. Actually, you can extend it. Like when you go in to sign up here and get your name in the redeem code, if you put all in uppercase, winter 23, then you'll have that extended for more than a month. The only reason I'm going here is because they have the full set of Deci blocks in here that we want to use. So I'm just going to sign into mine. We'll get going here. So this is the sheet that you're going to see when you come in. And to find them, go over into pattern blocks. And what we see here, and this would be the place that we would start, just like we did with the hands-on, we'd want the students to recognize which one of these do we use in our fractions. These all get used in different kinds of ways. Definitely the square and the very slender rhombus we didn't use in the fractions, but we will use them in pattern blocks and for other things that we're going to talk about in another video. But for now, we know that we used these particular shapes. And it is the the triangle that really fits into a lot of these. For example, 2 fit into the rhombus, 3 fit into here, into the trapezoid, and 6 fit into the hexagon. Now we would want the students to learn how to do that. So we want them to actually tile these. They could drag these over. They can pull out a green one. put it in, and then if you click on it, there's a duplicate right here. So I can just grab it. And for them, initially, that's probably the best way for them to do it, is just to practice putting them in. And then when I want to duplicate it, but I want to flip it over, because right now I need them to turn the other way, I can just go like so. I can turn it sideways. So I'll just grab another one. And I'll grab another one. Oops, sorry, my bad. Okay, so I can see where my 6 triangles. So it would be great for them to play at this point first and just get them used to finding all of those different values that we had before. Like here's our half, right? I would need 2 of those. So same thing, click it over, flip it, slide it in, and away we go. So it's a nice little way for them to just refresh their memory of what they did. Remember that 3 of these will fit into the hexagon, and then 2 triangles will fit in there, etc. And then what we also had them do was, could they put in a double hexagon? So I'm just going to turn this one sideways a little bit. Oh, that didn't fit well. There we go. And so when we have a double hexagon, that means the red now will be 1/4. And it means that when I put these in, they become 1/6, and so on. So again, just having them practice with that would be really, really helpful. Okay, I'm going to get rid of mine just by hitting clear all down here. And what I want to do now is I want to change what I'm going to look at. I'm just going to show you what else is here. You were in the basic workspace. These are the basic tiles that we were working on. Okay, I can also have a smaller triangle. And these are just portions. They're not necessarily Deci blocks anymore, but it gives you another way of expressing even a smaller fraction in terms of all of these. This isn't one that they have in their toolbox, but this is a great way for you to double check to see whether they actually understand what that is when we're putting these in, that this now becomes 1/2 of a green, which we didn't have before. The green was a half of something. So now we have a purple as 1/2 of that. So what will that make the purple for the blue rhombus? What will it make it for these trapezoids, right? So it just changes it. But this is a great formative assessment for us to find out, do they really understand this notion that when the whole changes, I can put shapes in and still have the same values of 1/2, just like we did in the Deci blocks in the hands-on one. How could they all be 1/3? Well, they represent 1/3 of a whole, but they don't have to be the same size because the whole might not have started the same way. Okay, so that would be the next step in the virtual one here that I would play with, because you don't have that advantage with the other with the hands-on ones. But let's go back down to the workplace, and we're going to go into Deci. So now I see all of my blocks. And the unfortunate part of it is, if they haven't worked with them, then this isn't going to be still an exploration piece. But because they're arranged in order, it's not hard for them to figure out that, you know, it kind of, this is the way it's going to go, and those are the pieces that we're going to build. So eventually they figure out that one of these will have one there, and I'll have another one here, and I can flip it. And in it goes, right? So I can realize pretty quickly that there's my 1, this becomes my 1/2. So in terms of the triangle, if the triangle is our 1 unit, our starting unit, then I can compare all of these in terms of a triangle. So again, they could practice building just like we did. What are all the different ways that I can build these? And then what is the one way that I can build it, or 2 ways that I can build it with just 1 color on each layer? So again, they could just start off with dragging these in, turning them sideways. Come on, turn here. Okay, put it in, and then put a triangle in. So remember, we said initially, we just want to take all these shapes out and we just want to build. How many different layers can you build on there? It doesn't matter what color they are, as long as there's no gaping holes and nothing hanging over. So I would put a triangle in here, and then I'd try another one. So I'd find that the red could also have 3 triangles. I'm going to say right now that if I put the blue the other way and have the green on this side, it'll be the same as the green and the blue, because in terms of adding the values of them, it's not going to change. But it does show you that the commutative property says it doesn't matter whether I go triangle this, rhombus, or if I go rhombus plus triangle, I'm still going to end up with the red trapezoid. That doesn't change. And that's a great way for kids to see it, because now they're seeing it in terms of color and shape. It isn't even quantity right now in the term of a number form that sometimes throws students off, right? So it just gives us that advantage. So I would have them, give them whatever time is necessary to pull out as many of these as they want and need to, and then what fills the dark purple triangle. In this case, only for one color will still only be the triangles. Can they fit other things in here? Sure they can. And they can piecemeal them together. Same thing with this one. I can piecemeal them together. I can even take the red one and put it in here. And I can see I need 2 triangles, or I can turn it over. So there's all different ways. They're going to do exactly the same thing we did in the hands-on. And I'm not going to go through all the activities that we did in the hands-on. If you haven't seen that, what I would do is go back and watch what we did in the hands-on, because that would be the same things that we would want the students to do here. And so eventually they're going to work their way down into here, and they're going to get to the what we call the boat. And the boat will fit 10 green ones or 5 rhombus. So the boat could be expressed as 1/10, or it could have a unit fraction of 1/5. And that's where we're going, is we want them eventually just to have one color on top of each one. And what is the unit fraction that they're building? Because then I could say in here, this is going to be 1/5, because I have 5 triangles in here. So I could say, what is 1/5 plus 1/4? So 1/5 plus 1/4. So eventually I have to come up with even the work that we did with Cuisinart rods, where we found that the common color when we're setting up our fraction tiles and we were doing our Cuisinart rods, same things. When I find a common row of color, I've also found a common denominator. And in here, I'm going to do the same thing. If this is my 1/5 and this is my 1/4, that means that each one of the purples is equal to 4 pieces. Every one of the pink trapezoids is 5 pieces. So if I had 2 triangles, I would have 8 pieces. If I had 2 trapezoids, I'd have 10 pieces. And how many do I keep adding up on both sides until I actually hit the same number? So I'm going to have 4 of these, because 4 at 5 will give me 20. This one had 4 to start with, so I need 5 triangles to get to 20. So once I have 20 and 20, I have a common means of comparing. So now I can say, how many purples out of 20 did I need when I'm expressing whatever fraction it was, 1/4. So there'll be 5 of them. 5 over 20 is 1/4. Plus, in this case, we said 1/5. So I needed 4 of those. So that would be 4 1/5 pieces. So out of the total 20s, that means I had 4 out of 20. Over here, I had 5 out of 20. Total is 9 out of 20. So I'm starting to build the concept of how many do I need in number, in total comparisons of triangles that would give me the same value that I can add them together. It is the same as when we did the basic shapes like this, and I said I would ask you to add, let's say, 1/2 plus 1/3. I can't add 1/2 if it's a red to 1/3, which is a blue, because I don't have a shape that I can just sort of yank those two together and make up a new shape. It doesn't work that way. So the only way I can add them together is find a common color. So we're moving from common color, triangle green, I can add them together, to this time it's what's the common number that both of them have. And eventually we would do the algebra with them and we would show them how we would get to that common denominator. But the visual is way more important for them to understand, first of all, what is it that they're trying to find? And then we can start working on, well, you know what, 4 and 5 are common factors of what number? 20, okay? They have 20 in common. So I can work from that value and show them how to do it, but doing the picture part first would be more important. So again, I'm just going to clear these off just so I can get rid of that for a minute. So when we're working with these, we want them to be able to have opportunities to see what are all the different pieces that will fit in here. So when they're layering them, remember it initially, they can put in whatever they want. And since this is a 6, we already know that this is sixes because there's 6 green triangles in here. This one will be a 7th. So the white one represents 1/7 because the missing triangle that we put in here, the green one, will make up the 7th triangle that goes into that diagram. So that means that this represents the 7s, or 1/7 if I'm talking about this being the unit. They'll find that this becomes 8s, and they'll think, oh, if it's 8s, well, I should just be able to take 4 of these guys, 4 of the rhombus blue ones, and just fit them in there. And we'd say, well, okay, try it. See if it'll work. If it works, great. If it doesn't work, then what else are your options, right? So then they'll find that the only thing that will fit in there are the green triangles. It's not that this doesn't total to 8. It's just there's no way to position this so that they all fit in here without having some holes someplace. So they end up having to go back here, and then they'll see that there are 8 triangles that fit into this. But then you also have questions that you can create by adding these pieces together. So for example, if I know that this is 8s, all of these sides have been equally measured that we can put pieces together. So what if, let's get rid of this guy here. I'm just going to take off so I can clean it up a bit. I want to take my 8s, sorry, and my 7s, and I'm actually going to just turn my 7 so it actually fits on top of there. So now the question is, odd as that shape looks, how many pieces are in there? What does that represent? So if there are 8 triangles in here and 7 triangles in here, this is the shape that is a 15th. One triangle represents 1/15. So now there's no limit as to what they can come up with. They can add whatever they want. So you could challenge them to say, you know, with a partner, can you find, and just randomly pick numbers. Can you find a 19? Can you find a 22? Can you find a 31? Not that those numbers are significant. But then at that point, once they get the hang of it, that they can just rearrange these and come up with whatever values they want, then we can start to go to those values, especially in grade 3 when we first introduce, let's say, the imperial measure, where the fraction is a really, really important piece. Then I can say, you know, can you find me 8s? Well, yeah, we know what 8s look like. It's this one right here. Okay, can you find me 12s? Right? Well, we didn't have 12s in here, but could I make a 12? Yeah, I could. I could take the boat and I could add in, let's say, one of these if I wanted to, or I can turn it on its side so it fits in here, or I can lay it on top. Doesn't really matter. There's 10 in here and 2 in here. This is now a 12. What else could I do? Well, I could have taken 2 of my hexagons and put them together. We already saw that as the double one in the pink. That makes 12. So there's no one only answer anymore to come up with some of these fractions. And the kids are quite engaged in being able to be challenged in what are all the ways I can find 12s? Which one of these shapes can we pull together? Can we make a 12 out of? And it's fun for them, for one, but 2, then they also learn that, again, nothing is written in stone here as far as the shapes are concerned. So I could take one rhombus here, that makes it a 12, but I could put another one over here, that makes it a 14, right? How do I make it a 15? How do I make it a 13, right? I could just take one of my triangles and bring one of my triangles down. Now I have a 13. So it looks like it's a bit of a ship and it's got a point on the front. So then they start making pictures, and I mean, that's the fun part of it for them. And maybe that's an activity that they get, is they get to have one opportunity too, where they just clear their screen and they get to make a diagram of an object, you know, ship, plane, whatever you decide, or they get to pick. But how creative can they be with the different shapes that are there? So it's just working with patterns. But this Deci blocks really has now opened it up in that we don't have to limit anything anymore to just those simple shapes that we had to start with. So hopefully that gives you some assistance. Braiding Camp, for if you're not familiar with it, behind the scenes here too, offers a ton of tutorials that you can use about any of the ones that they offer. So you can go in and learn more about how I can manipulate, how I can add some of them together visually. So it's not like you're also only going to just work on this screen. They actually have lessons for you that you can use if those are the things that you wanted to use in the classroom. If not, and it's just exposure that you want for them, then this is a kind of an activity that you might want to do. So again, great tools, wonderful place for them to be. So hands-on if we can. If we can't, we can always use the blocks in front of us that we have available to us, and then we can sort of augment the whole idea of what they've learned from the basic patterns into these shapes. Now, one other thing I just want to show you, I'm going to clear these off again. There is a little button down here called the grid. And when they're first trying to figure out all of the different one-colored layers that they can put on there, having the shape on the grid sometimes is even helpful in that sometimes students say, well, if I'm on the grid, I don't really need to drag all of the points over, because I can see that there's a triangle there, there's one here, there's one here, by following the lines up here. So they just start to count them. So you might find that this is helpful for them as well, just to have it on the grid so that they can do some counting through that, or they can build different pieces together, right? They can add some of these on, and then they can see, well, this one went across, so it'll have a triangle here, it'll have a triangle here, it'll have a triangle here. So it really does help them to see that they're able to just count them without necessarily dragging. I can double check. I know this is 6. I know that the other part is 2. So I was guessing it was 8, which 5 and 3 is 8. So yeah, I was right. So this is another way that they can verify for you that they understand what they're doing. So the grid in the background is really helpful. It's also helpful when you're trying to do just some basic addition and you're finding the different, like we did with the example of the 20s, where we had a 4th and a 5th that we were adding. So how many layers do I see? How many of these do I need to get to 20? Having it on the grid is sometimes a little bit easier for them to see. So just know that down at the bottom, you can turn it off at any time. Once they built it, they can turn it off and just go back to the main piece. You can also write on here if you want. Like if you wanted to write, I had 3, this turned out to be 8 pieces. So this is another 8th right here, another way of showing an 8th other than the trapezoid that we had. So this is another way for me to come. So I can write those on here that this is an 8 and each piece would be a triangle. There's no other way to do this. And oh, no, actually there is another way to do this. This is one of those ones where I could put 4 of these in. So I can put 1 here, 1 here, 1 here, and 1 here. So that I could have an 1/8 or I could have a 1/4 here. So again, they just play around and they get all kinds of different visuals that they can see. All right, thanks everyone. Feel free to just reach out to your consortia if you have any questions or connect with me and I'll be glad to answer any questions that I can. Thanks very much. Bye-bye.